Just want to do a quick run through of like everything that you need to know about these rectangles. It's basically all the properties that are listed on those filled in notes as well. So if you want to pull these out, these are going to be kind of helpful to kind of guide you through the video as well. All of the problems on here, like number 1 is very similar to number 1 on the assignment. Number 2 is done very similar to number 2. So basically these problems all kind of correspond to the same, almost the same numbers here, but we are going to do kind of a quick just run through of basically all the properties that you need to be able to do to solve some of these. So rectangles are still parallelograms. So because they're still parallelograms, they have all those same features of parallelograms. If you can think back to last week, parallelograms means that both of the sides that are opposite of each other are the same length, so they're congruent, and the other pair of opposite sides are also congruent. Now, the other thing that kind of comes with rectangles and with parallelograms are when you draw the diagonals in. So I'm going to draw those in real quick. You have these diagonals formed right here. And when we're dealing with rectangles, one of their main features is that these diagonals, they're actually the same length as well. So I'm going to label these real quick. So if I call this A, this is B, C, D. If this is a rectangle, then A to C, so I'm going to write this up in the bottom corner, A to C has to be congruent to B to D, because the diagonals have to be congruent. Now, one of the other features of rectangles are that not only are these diagonals congruent, so these lines that are diagonal, not only are they the exact same length, but they also cut each other right in half, because that is also a feature of a parallelogram, meaning that A to C cuts B to D in half, and B to D cuts A to C in half. But since we're dealing with a rectangle and the diagonals are the same length, it actually is going to mean that all 4 of these partial diagonals are all the same length. So this piece, this piece, this piece, this piece, all 4 of those pieces are going to be the exact same length. So that's something that you might be able to use on here. Let's see here. One of the other features of rectangles are that all of these angles in the corners, these are all 90-degree angles. Alright, so because these are 90-degree angles, that means that this triangle formed right here is a right triangle. Remember that in a right triangle, if you want to use the Pythagorean theorem, you can, because it has to always be true in right triangles. So if you can't remember what the Pythagorean theorem says, is that a squared plus b squared equals c squared. That means that if we're looking at this right triangle here, that means that the length of D to C, we could maybe call it A if we want. A. And the length of B to C, we would call it like B. So this side squared plus this side squared is equal to BD squared. So using the Pythagorean theorem. So that's pretty much all you really need to know about the sides of a rectangle. So again, the sides are all parallel and they're congruent. The opposite sides are congruent. Your diagonals are congruent and they bisect each other. So all 4 of these little pieces of the diagonals are all the same length. And because these are right triangles created by these right angles and then the diagonals and the sides, that means that you can use this Pythagorean theorem to solve some of these problems here.